Boys and girls. Today we are going to talk about theorem number 2 of circle geometry, which says angle at the center is twice angle at the circumference. What it means to me from the diagram is that if this is my angle, the letter O, which is the center, that's AB from the arc of chord AB. If I create another angle which is on the circumference C, then I can say angle AOB is 2 times angle ACB. That's what I need to prove as well. So if I start proving my theorem, if I want to prove my theorem, likewise the previous theorem, we started proving the theorem by constructing a radius. So in this case also we are going to do the same. I will construct the radius CO, but I extend it till D so that I can have two different angles at the center, D1 and O1 and O2, and C1 and C2. So I will start writing my work. Construct COD, which is my straight line. Out of that, CO is my radius. Now if I can see my diagram, I have two triangles. One on the left hand side is AOC and triangle BOC on the right hand side. So we are going to work separately, one triangle at a time. So if I can see on my left hand side of the triangle, I can see it, my angle A equals to angle C1. The reason is those are two angles, they are in front of two radii OA and OC. In short, it's the isosceles triangle. They are radii. Okay, similarly on the right hand side, I can see that angle B is equals to angle C2. The same reason angle B and angle C2, they are part of isosceles triangle. The reason is my two sides are equal in that isosceles triangle, which is OB is equal to OC. If I check account my knowledge of grade 8, which says the exterior angle, which is O1 in this case, if I want to write O1, I can say it's A plus C1, exterior angle of a triangle. Just now I have proved angle A equals to angle C1, so I can replace that angle A with C1. That gives me 2C1. So in short, I will end up O1 is equals to 2C1. Now if I look at the right hand side, similarly O2, that's my exterior angle of a triangle, which is B plus angle B plus C2. Exterior angle of the triangle. The same reason, exterior angle of a triangle. But just now I have proved in my previous step angle B equals to C2, which I can replace with. So I can say C2 plus C2, I will end up 2C2. So angle O2 equals to 2C2, angle O1 equals to 2C1 from the left hand side. Both the equations, if I can add left hand side, which is angle O1 plus O2, I'll be able to add 2C1 plus 2C2. If I take it out 2 common, I will end up with C1 plus C2. If I see my angle C1 and C2 combined, that creates angle 2C. Similarly, if I see on the left hand side angle O1 plus angle O2 combined, they will give me angle AOB. I came to the conclusion which I wanted. This question might be asked for 5 or 6 marks, depending on the question, depending on the examiner. I hope you have understood theorem number 2, which is angle at the center is twice the size of the angle at the circumference. It's very important theorem, and it's easy to prove, but it will have you will need to know this one when we are doing the detailed example where all the theorems will be needed. Okay, thank you very much for watching this video. Enjoy your rest of the day.